So once we understood batch processing, then it was a pain to do. It worked, but it wasn't pretty. So then we make it beautiful. So we wrote an open source project called Cascalog, which actually has now been adopted by other companies. And Cascalog is the perfect interface to our data. We just used our deep understanding of batch processing and then just put all that knowledge into this tool. So now when we do batch processing, it's really easy for us, and we get to focus on the problem we're trying to solve rather than the tools that are kind of getting in our way. And after we made Cascalog, we use it in production, we start using it for more and more things, and then we worry about making it fast, right? So, we profile it, identify bottlenecks, optimize it, do all those things, which have to come after the previous two steps. So I find that when you don't build software in this order of making it possible, making it beautiful, and then making it fast, then you can run into some problems. So one problem is over-engineering. So if you attempt to create beautiful software without a deep understanding of the problem domain, you are inevitably going to over-engineer. You're going to add flexibility, or you're going to add pluggability, or general interfaces or abstractions where you don't actually need them. Or you're going to build a bunch of stuff so you can do this one thing really well, but as it turns out, maybe it's this other thing that actually mattered. So then this was all wasted work. I think I've just found inevitably if you can't build great software without understanding the problem domain first. And inevitably this does lead to you needing to do rewrites. But if you build it the fast way first, hopefully it's not too much of wasted work. I find that when you try to optimize before the other two steps, you end up with premature optimization. So you can't optimize something you don't understand. And when you try to optimize before you build a beautiful interface, then you're going to hurt your abstractions and you're going to hurt the code, or the optimal code. Okay, so the next thing I want to talk about is this concept called knowledge debt. So the idea here is that you and your team have a certain amount of knowledge, right? You're good, you understand certain tools, you understand how to solve certain problems in a certain way, right? So on the left side is your productivity with that knowledge. On the right side is your potential productivity if you knew how to use every tool, right? If you knew how to, if you just knew how to use everything. And that gap I call knowledge debt. Right? And your knowledge debt just increases every day. Every day people discover new things, people build new projects, release new open source, and you don't know it, so you can't make use of it, so you're not as productive as you could be. So we do a BackType to kind of battle knowledge debt and keep ourselves increasing in productivity over time, is we kind of keep abreast of new technologies, keep track of technology that looks interesting to us. And then, sometimes we have this small project that comes up, some small independent project from the rest of our code base, and we'll use that project to experiment with new technology. So rather than build it with our known technology we know and are good with, we'll try some new piece of technology. So let me give you an example. About a year ago, a little bit more than a year ago, I needed to write a small server that would collect records into a distributed file system. Pretty small project. I didn't anticipate it being more than 500 lines of code. And I could have wrote it in Java or Python, just using the stuff I already knew. But there was this programming language called Clojure, which was really interesting to me. Clojure is a dialect of Lisp, for those of you who haven't heard of it. And I'd always been interested in Lisp, I'd never used it before. So I thought, what the hell, this is interesting. The people in the community seem smart. Let me write this in Clojure. And it was amazing, a total home run. I love the language, by far the best language I've ever used. And the result of this is that now we use Clojure for almost everything, right? And Clojure makes us more productive and helps us avoid complexity. So another example, we were working on this social search feature. So the idea was that you could search for a term, and then we would look at your social graph to get related stuff to that term. And we could have used this, again, we had expertise in tools that could have solved this problem, and we could have used those tools. But there was this database that we've been reading about called Neo4j, which is this single machine graph database. Looked interesting, so we thought, okay, let's do this project using Neo4j. and we implemented it, and Neo4j like really sucked for us. Like it would had these bizarre concurrency issues, and it would like corrupt itself all the time, which was obviously a problem, and just like needed a lot of like hand-holding and maintenance, and like it just didn't really work out for us. So later on, like we had to rewrite this using another tool called Sphinx, but that was okay. Like we tried it, we experimented. Now we had the knowledge of Neo4j. We had this other tool in our toolbox, and because it was just a small independent project, it wasn't that much work to replace later on when we needed to replace it. So another example, something this actually is like in the past month, we've been building this distributed stream processing system. So it's just this computation system that runs on like a cluster of machines. And we just wanted some sort of like deploy that could automatically like provision and configure these machines. So one button and now you have this. The project's called Storm, so you have this Storm cluster. So we've been using this thing called Fabric, which is this Python library for doing deploys. There are things that's good about it, things that aren't good about it. So we're looking for something better, something more robust that can do more things. And there's this closure library called Palette, which looked really interesting. It kind of competes with things like Chef and Puppet. But Palette looked the most compelling, so we thought, okay, let's do this deploy using Palette rather than doing the stuff that we're familiar with. And this, again, has been a massive win. Like the most beautiful, like I didn't know deploys could be so like beautiful as Palette makes them, and like robust, and it like turns like infrastructure, like provisioning configuration into like functional composition. Like it's really awesome. So it was a huge success, and now we're using it for more things. And I anticipate that within a few months, in the next 6 months, this will lead to a dramatic reduction in complexity for us to administer our infrastructure. And it'll let us like do new things that we couldn't really do before. So one more thing I want to talk about, knowledge debt. So I really like this strategy of using these small independent projects. But what I have here is kind of like a typical job ad. We see this company is looking for someone with 2+ years of Java experience, an expert in MySQL, and they have to do some generic things with that. If I had to guess, I'd say this company does their work in Java and uses MySQL. And what they're doing by hiring just another developer with the same skills, they're kind of homogenizing the skill set of the development team, right? But this is like what everyone does. You always look for people with your skills. But just as food for thought, consider hiring people who have a completely different skill set, right? Because now you get people experienced in different technologies that can now bring that knowledge into your organization. You can kind of get that knowledge for free. So just that's just food for thought. Just consider that. At BackType, we certainly don't list any technologies on our jobs page. We just want people who are smart, who can learn and get things done. Okay, so let's check the time. So next thing I want to talk about is technical debt. So has everyone here heard this term before, or are people unfamiliar with it? Who here is familiar with it? Okay, no one is, or just very few. So the idea is that like as you work on like a code base and like you iterate on it, these like things build up which are called technical debt. So like some examples examples of this are like this piece of code like needs to be refactored, right? It's just not very good. Or like you have some deploy which just like you wish would be faster so you don't have to wait on it. Or like this piece of code like you were lazy and it needs more unit tests and you wish you had more unit tests, or this other thing needs more documentation. But these things are just like never like high priority, right? It's just these little things that build up, they kind of like annoy you, get in your way, and they slow you down, but you never really work on them because you need to like be building new features or fixing bugs or doing all these other things. So we do a BackType, this is like debt, right? And it builds up, and the more of it you have, like the more it slows you down. And we want to stay lean and we want to stay efficient. So what we do to battle technical debt is this event we have once a month, which we call Backsweep. So the idea is that like whenever we encounter some technical debt issue, we have this wiki page and we add that item to the wiki page. And it's just a big list of items. And then one day a month is dedicated to removing items from that page. So we all get together as a team in the morning. We kind of look through all the technical debt items, and we kind of just like, everyone just takes a few of whatever they think they can do in one day, And then everyone goes and knocks these things out. End of the day, you cross them off the list, and the next day you go back to working on the stuff you're usually working on. So this has kept like our code base really lean. And more important than just like resolving technical debt and making us efficient is now it gives us something to do with these things, right? So rather than like encounter this issue and then like say, I don't know, I can't do this now, and just like ignore it, you just write it on the wiki page, and now you have a way to deal with this. I call this like process garbage collection for the code base. Right, so like how like a programming language will do garbage collection for memory, this is kind of garbage collection for the code base itself. And BackType has been just like, it's like very low cost for us, and it's effective, and it just like keeps us happy as developers, not having, being able to do something with like the crap, unfortunately, that we occasionally produce. Okay, so the next thing I want to talk, so a lot of what I've been talking about so far is like how do we keep ourselves efficient, how do we become more efficient over time. And I want to talk about more like how do we decide what to work on, and how do we avoid working on things that don't matter. So we're a startup, and I really like this definition of a startup by Eric Ries. Eric Ries is he's like he's like spearheading this lean startup movement, and he defines a startup as a human institution designed to deliver a new product or service under conditions of extreme uncertainty. Now the key here is the uncertainty, right? It's like you don't really know if people are going to care about what you're building, right? And you really don't, you don't want to waste 3 months building a feature or product that no one cares about, right? Because ultimately a startup is constrained by people, time, and money, right? And you really don't want to burn 3 months of capital if you don't need to.